Good everyone, my name is Graphics. In this video, we want to solve a problem involving isometric projection, where the question goes like this. It says a cone of height 50 millimeter and a diameter 48 millimeter is resting on HP, keeping its axis vertical. Draw the isometric view of the solid. Now, there's something you need to understand. The word HP means horizontal plane, and every center line that connects the base of the cone to the apex is called the word the axis, just like you can see on the figure that is displayed at the right hand side of the screen, right? So what you need to do, we need to draw our horizontal plane. Let me take my instrument this way, right? And I'll draw my horizontal plane here, this way. So that is my horizontal plane, right? And I will take my set square and I will draw the axis to represent my vertical plane this way. Is that again? So from here, we are told that the base, right, is resting on what? On the HP. So the base is here and the base is given to be 48 millimeter diameter. So I'm going to measure half of it, half of 48. Since you had the word diameter, so we need the radius in order to get diameter, right? So I'm going to measure half of it from 0 to 24. That taking now, and I'll place it at this point here. I'll mark to the left and also I'll mark to the right. You can see that, and I am going to what? I'm going to thicken it. So thicken it from this point to this point. You can see that, and also I'll say this beginning here is point A, while here is what is point B, and I'm going to connect the highest points here because we're told that the height is given to be what? 50 millimeter, right? So I'm going to measure 50 from the base of the cone this way. So measuring 50 from the base of the cone this way, this is what we're having, right? This is what we're having here. This is 50 here. Is that taken? So I'm going to connect it from this point to that point here. I will do this 50. I'm going to draw my line that will connect it this way. You can see that? And from this point B to this point here, I'll draw another line to this point. So see that point is my point C. Let's call it point C. This is a triangle. The vertical line here is called its axis here. Now, if I should extend this center line here this way, if I should extend it downward, now we are given that the diameter is given to be 48, right? So we need half of it, which is 24. We know from here to here 24. So I'll pick any point here, right? Any given point here, and I'm going to draw my circle this way. So this point you're seeing, this circle you're seeing represents the plan, looking at it from the top, right? So I can easily draw this center line along one shot this way. And I can easily make here also to be a center line too, this way. You can see that? So this center point here is still given as my point C, right? And here is also, this is my B, and this is my A. So we'll move forward. So in going forward here, the next thing is we're told to draw this. We have successfully drawn this in our orthographic projection. So we're told to transform this into what? Isometric. So what you do when you do isometric is for you to draw your vertical and your isometric axis, right? So this is what you're going to do here. You take your t-square and you take your set square, right? And you draw your vertical line this way. and you draw your axis, your x and your y axis. So you have this. You can see that. Now, this axis you're seeing here, when you do isometric, the axis of isometric are inclined at what? Angle 30 degree. That is why when I place my set square this way, this is 30. If I bend it this way also, this is another what? 30. You can see that? And we're giving the diameter of it to be what? 48. So I need 24. So we know that from this point to this point is given to be what? 24, right? So I'll place it at the center point. Let me call the center point point O here, right? So from this point here, point O, I'll take the entire distance here, which is 48 this way. You can see that? And I'll place at point O. I'm going to mark towards the right and towards the left. And I'm going to take the entire height. Height is from the elevation, right? I'll take the entire height here from this point to this point, which is 50, and I'll come here and I'm going to mark 50. You can see that. So I'll use my set square. I'm going to extend all these points I marked here. I'll take them up. I'll come here also. All these points I marked here, I'll take them up. You can see that. And I'm going to close here up too. So in closing here up, I'll have this, right? And I'll have this too, this way. And I'll move here too. I'll have this. And I'll have this way. You can see that. So I have successfully brought out this shape out here. So just know one thing, what I used to draw this line is what I'm using to draw this line here. Start taking. So for me to get complete this, right, to form this shape here, a square. So when I place my set square on my T square this way, I'm going to have this. I'll turn it this way around also. I'll come here, I'll have this, right? So if I want to get the center of this figure here, I'm going to connect the word diagonal. From this point to this point is one diagonal. From this point to this point, another diagonal. So I'll just place it this way. From here to this point here is diagonal. And see that? And we already have this with another diagonal here. If I call here to be O, I'll call this point here to be what? To be P. Right? Now what I'll do is I'll place my compass this way, my T square this way. I'll move it to get to the center. This is the center here. Let me call the center to be what? Center arrow. So to go to center arrow here, I'll draw a line across arrow, right? And I'll come here also, I'll turn it this way too. I'll draw another line again across arrow. So this is arrow here now. Here will be what? X. Here will be what? B. Here will be what? T. And here will be what? V. Right? So what we'll now do next is I'm going to connect from O. This is how you can draw your what? Your isometric circle, because the base is what? Is circular. So I'm going to connect O to what? To V this way. And I'm going to connect B to V also this way. Right? B to what? B to V this way. So where they meet, they're meeting at this point here and this point here. I'll call that point to be Y and what? Z. So from O, right? From O here, I'll place it at B, or I'll place it at what? From, like I said, from O, you take your compass to V or to B. Is that taken? take your compass to V or to B this way, and you draw an arc, is a curve this way, faint line first of all. You do the same thing too from P also. You do the same thing, take it to B, right? And you connect. So I can easily just take in this. And you have my reason. Do you see that? Then from Y, let's see to what? To V or T, any of the two. You start taking any of the two here. Just faint line first. Then from Z, place it at B and you connect any of the two. This way. Now this is the base of the cone here. Now we need the what? The apex here, right? In order to get the apex, or we'll call it the vertex here, you are going to also join the diagonal of this rectangle or this square at the top here, this square, right? I'll join this to this point and this to this point. So where they meet is the what? Point C at this point. So I will draw a line that will be tangential to this arc here. How will I do that? From this point here now, I'll draw a line that will be tangential to the side of what? Of this base here. That again. Once I've done that, I'll be having this. Right? I'll come here also, I'll do the same thing too. Draw a line that is tangential to this point. You can see that? So you can now thicken the base here. So all this base here now, I am going to what? Thicken it, and this is what I am going to have. So this is what we have here, right? So anything you see behind this will be hidden because the cone is a solid. So this one is behind it, so we cannot see it. So either you use your hidden line to draw or you just leave it that way. So we have successfully interpreted the question. We converted this question here to what? Into isometric. So if you found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.